Hello, welcome to Flip This Classroom with Dr. Platko. We're going to finish chapter 5.4. So we are on 5.4b where we kind of apply some more sum and difference thoughts. So this one says, example 1, find the value of the expression without using a calculator. I just put these in here, the book puts them in here because they want to remind you about inverses. So remember to use your order of operations. Whatever happens in the parentheses must happen first. What's the inverse cosine of 0? That's saying, tell me the angle where the x value is 0 on the unit circle. Well, an inverse cosine problem can only have an answer on the top. So where the x values are 0 is right here at pi over 2. Minus, this is saying, tell me the angle where the x value is positive 1. The x value is positive 1 right here at 0. So this problem is simply, what is the cosine of pi over 2? And the cosine of pi over 2 is 1. For the next problem, oh, look at that, a nice surprise for you all. This came out of the Sunday paper one day, rhymes with orange, the answer key to the universe. So there's this guy climbing up the mountain. Obviously, he wants to go talk to that guru up there. And, what do you know? Don't bother asking him all the questions for life. He only has the solutions to the odd numbered questions. Isn't that quite funny? Okay, on with our story. Example 2. Find the exact value of the trigonometric expression given that sine of u equals 5 over 13 and cosine of v equals negative 4 over 5. Both u and v are in quadrant 2. So it's asking you to find the sine value of u plus v. Okay, in order to do this, you need to be thinking, I hope you're thinking it, bow tie angles. So I am going to draw two different triangles because u and v are different angles. So when I draw this in the second quadrant, I'm putting, this is part of a bow tie. It would be the upper left-hand corner of a bow tie. And this would be another one. Now I'm just sketching, so I don't know if these are appropriate lengths or dimensions. I'm going to put a U in here. This is angle U, and this is angle V. And I need to figure out how this relates to that triangle. This is Y, this is X, this is Y, this is X. So the sine of U on this triangle, opposite over hypotenuse, is 5 over 13. 5 divided by 13. That is not a problem at all because this is a positive direction and the hypotenuse is always positive. On the next one, it says the cosine of V is negative 4 over 5. That's adjacent over hypotenuse. So you have to determine if the negative applies to the 4 or the 5. Luckily, this makes sense that the negative x value would be negative 4 and the hypotenuse is 5. It's always, the hypotenuse is always a positive value. Both of these triangles are right triangles. So we could use the Pythagorean theorem to find the third side. I know what this side is because it's a Pythagorean triple. So a squared plus b squared is c squared. I know that 5, 12, 13 always makes a right triangle. So I'm going to put my 12 here. And should it be positive or negative? You decide. It should be negative. So, sorry folks, just a couple of interruptions there. That's what happens when it's a teacher workday. You get interrupted. So a squared plus b squared is c squared. We know that 5 squared plus b squared equals c squared, which was 13. So 25 plus b squared equals 169. B squared, subtract that 25 from both sides, you get 144. So b is equal to plus or minus 12, and it's directional, so that's why it's a negative 12. Okay, on with our story. We know that 3, 4, 5 is a Pythagorean triple. If you want to do the Pythagorean theorem to verify, you may. Now we need to go ahead and realize that we are doing the sum of sines. So we will take the sine of u times the cosine of v. There's no sign change, it's a plus. Cosine of u times sine of v. The sine of u is opposite over hypotenuse, right triangle trigonometry, 5 over 13. The cosine of v is adjacent over hypotenuse, negative 4 over 5. That was also given in the problem. plus the cosine of u, adjacent over hypotenuse, negative 12 over 13. And finally, the sine of v, go back to v, opposite over hypotenuse is 3 divided by 5. Simplify, multiplication. 5 times negative 4 is negative 20. 13 times 5 is 65. Plus negative 12 times 3 is a negative 36 over 65. Simplifying, adding these two together because they have a common denominator is negative 56 divided by 65. And that is all we're looking for. Last problem of the day, another short video. It says verify the identity. This one is pretty short, and there are a couple on your homework that might be a little bit more intense than this, but you guys are at a point where you should be able to recognize identities and apply all the mathematics concepts no matter what identity is thrown at you. So looking at this, I'm going to start on the left side because it appears more complicated. I first focus on the cosine of x plus y. What I need to do is do a sum of cosines. So cosine of x times cosine of y, sign change, minus sine of x times sine of y. That's saying that this part right here is equivalent to what I just wrote. Plus, I have another cosine to verify. I'm not liking all these markings. I've got to get rid of them. Another cosine. So cosine x, cosine y, the sign change, so this will go from minus to plus sine of x times sine of y. Looking at this, do I have any like terms that I can combine or simplify? So I have cosine x, cosine y, cosine x, cosine y. I have two of them. So 2 times cosine x times the cosine of y. And then I have a negative sine of x, sine of y, a positive sine of x, sine of y. So those two will simplify to 0. So you're done. You finished this problem. You ended up with what was on the right. Okay, that concludes video 5.4b. I'm sure you guys enjoy that it was only 7 minutes long. We will probably be pairing it with something else, I assume. Have a good night. Sorry for the interruptions.